Well, this tutorial is going to look at rendering a depth pass from Mantra, and then look at creating a fake depth of field effect to demonstrate the use of the depth pass. I've got a scene set up here with a camera and some lighting and some spheres arranged, as you can see. So let's start by outputting a depth pass, and I'm going to put down a Mantra node. And the way to output a depth pass is to add an extra image plane, and we can do that in the Properties tab and the Output subtab. And if we go down, we have an option to add extra image planes. So I'll click the plus button, and that gives us the options for an extra image plane here. Now, the depth information is in fact one of the standard options that you can select here in this drop-down box. It's PZ, that means depth. The reason it's PZ is because when Mantra is rendering, it's looking at everything through the camera, and it uses a coordinate system based on the camera, so the depth of something in camera space is just the Z coordinate of the position. Now we need to quantize this as a float. 32-bit float is best, because of course depth information isn't limited to being between 0 and 1. The sphere could be at 0, this one could be at 100, for example. Let's render that out and see what we get. This is where we can select the image plane to view, so we can view the PZ image plane. And there we are seeing a nice depth map. But there's a problem with this, which I will show you first by looking at the color plane. And if we zoom in, we can see that the edges of our objects are nicely smooth, and that's what we normally want in a render. The reason for that is because here on our Samples tab, we're taking 3 by 3 samples. So for every single pixel here in the image, Mantra is shooting out 9 different rays. And if we're on the edge of the sphere here, and that edge of the sphere occupies part of the pixel but not the whole of it, some of those sample rays will hit the sphere, some of them will hit the background. And what Mantra then does is average the results of that, which is why we get a pixel like this one here, which is partly blue, the color of the sphere, and partly grey, the color of the background. At the moment, by default, the same thing is happening to our Z depth information. You can see it's blurred here. But the blurring of Z depth information doesn't really make any sense. A point is either on the sphere or on the background. It's not halfway in between, as this pixel here might be with the current setup. So we need to ensure that our Z depth information is rendered without this blurring. And we can do that on the Mantra tab, if we go back to the output options, by looking at the sample filter and pixel filter options. So we need closest surface on the sample filter, and we need closest sample filtering here. And if we render again, we should see that we now have a Z depth pass which is not blurred at the edges. Color pass is still blurred, and that means to some extent there's some incompatibility between the Z depth values and the color, because here we've got a mix of the object behind and the sphere, and yet the Z depth will just be either on the sphere or the background. I mention that because it's one of the key problems with Z depth compositing, when you would want to composite an object between the sphere and the background, for example. But for the effects that we're looking at today, such as fog and depth of field, this slight difference between the Z depth information and the color information doesn't really matter. So I'm happy with that, so let's render it out to a file, which I can do up here. like so. Note that you can render the depth information to a separate file if you just tick this click box, and you could use a standard format for the depth information such as a 32-bit TIFF file, but for the demonstration today we'll just stick to the PIC format, which allows us to include the Z depth information in the file with color information. So let's render that out. And now let's set up a compositing network to bring that depth information in and use it. So the first thing I need to do is use a file node to bring in the image we just rendered. There it is. And let's switch to the composite view, and we can see that we have the depth information. Let's start by demonstrating a fake depth of field effect. And to set this up, we're going to need the depth of field node. Now, the depth of field node doesn't in fact itself create the effect. What it does is create a mask that we can use to blur the image selectively. So the focal distance here tells us the distance at which we want things to be sharp. So let's have a look at our Z depth. If I hit I can bring up a pixel inspector, and let's try and put these middle spheres in focus, and they're at a depth of 11.5. So let's put that in. Now, what this has done is in fact create a new channel in our image. You can see here we now have a channel called M, and that's going to be our mask information. And to see it, I'm going to have to use the equalize button, and we can see that's going to blur things here and here, but not here, because this is going to be a mask which tells the blurring function how much to blur. Dark will be less blurring, white will be more blurring. And to use this, we need to use a defocus node. So let's lay one of those down. Let's put the results of our depth of field node into the mask channel of our defocus node. And on the mask channel here, we need to select M as the mask. Let's display the defocus, and we need to put our original color image into the main input. Okay, well, we're not getting much of an effect at the moment, so let's increase this. And a bit more. And it doesn't seem to be doing anything very much. And the reason for that is that we need to enable perfect pixel defocus, and that will then take into account the mask that we're feeding in here when it's doing the defocusing. And now we can see that these front spheres are starting to be slightly blurred. We can control the extent of the blur both on this node here and also here on the DOF node. If we increase depth adjust, that tends to blur the image, as you can see, rather more. Another use for Z depth information is to create fog, and there's a node that comes in the compositor which does this automatically. So let's feed our original picture into that and set it. And we can up the fog density, like so, and we can add noise to the fog, like so, and so on. So that is a quick demonstration of how to create and then how to use a Z depth pass in Houdini.